All right, my friends. Where'd everyone go?
There's a lot of people absent.
Yeah, oh yeah, there are a few people absent today. So one of your classmates, I forget who, somebody in this class, reported, and it might have been Gwendolyn, reported that their favorite way to learn is when the teacher just like tells you what you got to do, and you just like go, just do it. Okay, go. So my thought is that we run a little experiment today and see how well that works for this class. Because this is the accelerated class, right? The advanced. You guys said that you're up for the challenge and you're going to work hard and everything else. Hey, why am I competing with people right now? So we're going to do a little bit of setup and start our lesson together. But then I'm hoping to be able to just like, okay, now work for 5 minutes. And then I can like filter around the room and talk with all you guys, but not whole group. And while I'm doing that, you guys are going to be writing stuff on the board. And then we're going to move on to the next problem, and then you're just going to work on your own and figure stuff out, and then we'll bring it back together and check it, and then move on, and you guys can just work and do your stuff, and then we'll check it. Like, I don't really need to guide your learning. I just got to check answers and make sure that we all understand everything. So, the reason we're doing this, the whole first section is review. So we are now in 121 today, Introduction to Probability, which actually I'm going to flip screens and keep this down here, so I'm going to start a set of notes. So please head your notes. 121, and you don't have to write introduction to, you can just write probability. It's the 29th all day. At least I sure hope so. Probability. And our first question is going to be 50. And while we wait for a couple more of our classmates to get back, when we set up 50, we're going to have 3 different lists. Impossible. Uncertain, which means maybe. And certain, which I'm just giving you guys the straight math words because we're the advanced class. I don't necessarily need to give you the easier ones. Certain means it will happen for sure. Right? Certain. I'm certain I will go home today after work. I'm certain I will eat lunch that I brought with me. I'm certain. So, yes. Would anyone like to read for me? It's a short intro today. You have probably. Aaron, go ahead.
Yay! You have probably heard weather forecasters say that the chance of rain tomorrow is 40%. Have you thought about what that means? Does it mean that it will rain tomorrow for sure? What is the chance that it will not rain? In today's lesson, we'll investigate the chance or the probability of something happening or not happening. As you do the activities, ask your team, what is the probability of the event occurring, and how can we record that probability?
Wonderful. Now that second question, how can we record that probability? Most people make the mistake of thinking that probability is given in percentages. That's actually not true. Percentages is a like another representation that we can use for probability, but the probability itself is a fraction. So before we dive in, we want to make sure that we understand what really are percents. What does percent mean? And if I put a little hyphen there, I like really easy. Simon? You're good. Tag team. Ooh, yeah! I'm going to modify that just a tiny bit. Out of, because per normally means like for every or out of. Now you could put for every here if you want. Out of 100. So what that really means is if you have, I'm going to make an example here. If you have X percent, that's X out of 100. That's what that means. So if we talk about the probability and then we extend that fraction to be out of 100, the numerator is then our percent value. Take at least 3 minutes. I will give you at least 3 minutes to come up with, on your own, impossible events, uncertain events, and certain events. Events. So like last class, I had a lot of people just trying to write like percentages there. We're not looking for what percent describes this. We're looking for like events. Like me eating lunch, or me growing wings, or like my little brother being a superhero. Like, so events, right? Things that can happen. Then, as you think you got good ones, and try to be kind of short with them so we don't spend a ton of time up here, come up and add stuff to the list at the board. So send somebody from your team up to scribe for you and put stuff on the lists. If there's a bunch in one list, try not to keep adding to that. Let's put stuff in every column. Quinn?
How many?
Just do it for a few minutes. Like some groups will be faster than others, so I'm not like really putting a firm number on it. All right, dive in. What if you use a catapult?
Well, that's not technically flying. That
Thank
is
you.
projecting.
Projecting.
Yes. You are projecting a thing. That's uncertain.
Or are we ejecting? Oh, green doesn't work. I have the oldest smartboard in the building. No joke. The green sensor doesn't work. If you want green pen, and this is how you make your writing look fancy, you click this and you go to calligraphy, and then you can change color to whatever you want. You can actually change color to whatever you want, but some of them you can't see very well. So like that, you're not going to be able to see all that well because it's a really light color. That's why I use like blue and purple and red and like bolder colors. But you guys keep talking and then you come up and add this stuff. If there's a big line, don't come up. Like, don't just stand up here and wait. V-E-N-U-S. Venice. Like Venice. Not Venice. Unicorn toy in water. What water?
Dying. So that is
One day, like 1 day away?
No.
Tomorrow?
No, just like little days, sometime.
Actually, there's some interesting studies right now on life expectancy getting longer because the healthcare and everything.
But
You
still
can treat
one
all those
day.
things. Yeah, eventually. Now, what if instead you get cryogenically frozen? Does that count?
That makes sense. It does suck, but
What if they offered you to freeze yourself and come back at a certain point? Like you said, all right, come back. And well, what if they froze themselves? You guys can walk back and do like frozen family movie? All right, impossible. We're gonna travel to Venus. Yeah, right now, tech we have, we're not getting there. And there's really not much point for what we know of the planet.
You would want to travel to
Can't
Mars.
get there, like.
Like, if anything, you would want to travel to Mars.
Yeah, if anything, we would go to Mars, and we could. So actually, the uncertain. Yes. And with our current administration, you never know. Now, uncertain, we could put travel to Mars,
Yeah.
right? Because Elon Musk is leading expeditions to Mars, and like pretty soon, people, and pretty soon by that I mean like within the next decade or two,
Still
people will be
pretty
going to Mars. You.
Colonizing Mars.
Now, this is one of those big things that Mr. Sherg will be mad at me about because he wants it to be like, be your best today, be your best now. You could, your future best self, hopefully, could go to Mars. Right? Like, that's real. For you, that's a real potential.
I really like it.
I like
Alright.
I like it.
Yeah. Hold on. Quinn's got the floor. Problem is, they all think we're still doing the conversation thing. Hey, we're gonna wrap this and then move on. So Quinn's got something to say.
It's saddening that about the whole thing to going to Mars thing is that there was a rover up there that recently got buried by Sandstone.
Really?
Yeah.
They're probably gonna figure out how to get it out. They're pretty smart. All right, let's look at 51. Sorry, Mike, you got something? You got something? Sorry, dude, I don't know your guys' names yet. Hold on. Let me look at the list to know who I got to choose right now. You know, if you had out that thing that, I've asked you to have it every day, that would be really helpful. Braden. Dude, you just don't look like the Bradens that I've had before. Sorry, my brain is struggling to say that you are Braden.
Okay, for I have one for I mean, I know this is kind of but I have one for so traveling is light because that's very impossible.
Right now, yeah, that would kill us.
Yeah, that's one of the rules.
Now you can travel at the speed of sound, though.
Yeah,
You can do sound.
That's
It's on
That's
Yahoo.
possible. But you only can you can't travel at the speed of you can travel something.
Yeah.
Travel.
Yeah, we break. So when you travel at the speed of sound, there are vehicles that can do this, and the vehicle will pass you before you ever hear it, because the sound can't keep up with the vehicle. Yes. We can watch a video in the class if you guys want. If we get through a malady. And then we're moving on. Last one.
I have one for uncertain.
Yeah. Yeah. It's which we check the menu, but even then, who knows? They can run out or whatever else. So wait, do you wear glasses?
Yeah, but I'm wearing.
Okay, because for some reason I was thinking that's Micah, and right? Yes. And if you take your glasses off, you guys look pretty similar. I'm sorry, I will fix it in my brain, but yeah, sorry. There's only so many facial types my brain can really delineate all at once. 51, we're going fishing. You take your significant other, and we're going to draw these lines tomorrow because I got to make sure I do that with Math 7, so we're going to skip the rest of this for now. You take your significant other to the fair, or Cedar Point, or wherever, and we are going to play a game where they have 3 prizes. Has a giant stuffed animal, a smaller stuffed animal, and a kazoo. The game is set up with a tank containing 1 green fish, 3 blue fish, and 6 yellow fish, hence your bag on your desk. To play, Mike must go fishing. Now, here's the deal. The game is set up that every time you put your fishing pole in, you will get a fish out. So if you don't, they let you play until you do, and then that's the result. So you're going to win a prize every time. So simulate this with your bag. Then, now be careful. These 3 questions are all unique and kind of modify the situation a little bit. A is if somehow all the fish in the tank became green. How then would we express the probability of getting green? B has 2 parts. The way the tank is set up, what's the probability? And then, what are the chances that Mike will catch a blackfish? Now, we can talk about that 2 different ways. We'll talk about it when we get to it. Then, given the information, what percent of the time? So we're going to need to change this into a fraction involving 100 on the bottom. So dive into that with your team. I'll give you, again, at least 3 minutes. All 3, A, B, C.
So,
All the fish
Somebody wants to go.
100%. What if someone?
Well, maybe technically there's 0%.
No, because there's no.
He doesn't say what time. Blackfish would be caught. 0% of blackfish would be caught.
But dude, why does it? I can just stick a blackfish in there and there would be 3%.
So we're gonna look at both ways. What is it as the tank as it is, and what is it if somebody drops it?
And then C.
So as it is, it's 0.
I'm sorry.
I'm playing with gravity. Because this bounces,
It does?
so I'm not like impacting gravity, but this stays. They're weighted well, like I just like how the weight is distributed.
Alright, so C.
Right. This is how I wait for you guys to do your math.
Yeah.
If all of the fish are green, OP, help me out. What would we then say is the probability, the chance, the whatever, if they're all green? 100%, right? But what? Sorry, what? It says every time they'll pull one out. So like magnets or something else. They're not real fish. They're like game fish. Now, B, we actually have two different ways to look at this. As the tank is set up right now, what is your probability of getting a black fish, Olivia? Wait, Olivia's sick, right? Well, I thought I saw on the list. Not coming. Chloe, what is the probability of getting a black as the tank is set up right now? 0%, right? Because there are 0 blackfish out of how many fish are total in the tank right now?
6, 2, 4, 6, 8, 10.
10.
Oh, there are 6.
Now, what if someone has been messing with the game? And you ask this question because somebody has placed a blackfish in the tank. Ooh, say it louder,
It would
George.
be a 1 out of 11 chance to get a blackfish.
So then, B-L-A-C-K, if there was 1 blackfish in the tank, that would mean that they've increased the total by 1. So depending on the situation, it's either 0% or 1/11, because you have to add that other fish. And unless you took another one out, we now have 11. As it stands right now, what is the percent of green? So to find the percent of green, we gotta start somewhere. What?
We can take 100 and divide it into 10 because that's how we fish it out.
I kind of agree, but I'm gonna take it a different route just to make sure you guys are comfortable with this. So I agree that we need to like multiply by 10 somewhere, right? Because we need 100. First, I want us to start at our fraction 1/10. Now, I wrote this, and I'm going to take your question in a second, but I needed you guys to be aware of proper probability notation. P parentheses something is how we write about probability. That statement right there means the probability of getting whatever you put inside the parentheses. So you put ace in there, probability of getting an ace in a deck of cards, or you put rain in there, the probability that it's going to rain today. Like, whatever's in the parentheses, that's what we're talking about getting. So then this is how many ways I can get that thing, and then how many total outcomes there are. So there were 10 fish in the tank. One of them was green. But if we want to extend this to percent, Quinn said, well, we really need to talk about out of 100. So if we make the tank 10 times what it is now, well, I can show the math by doing times 10. What's my numerator become? 10, which means my percent, 10%.
I did a 7.
You did many things. Any questions with that? Yes.
Why does it say 11 and then up there?
So this was a specific situation if somebody had came over, screwed with our game, and put in a blackfish. But then in C, we're saying that didn't happen. Nobody messed with our game. It's back to how it's supposed to be. You shouldn't. 3, 6. Oh, they miscounted their 6. You should only have 6 of those. Sorry, somebody who made the bag. I had kids help me make the bags, so somebody miscounted. All right, let's move on to 52. I don't know why, but when I talk about the gillfish problem, I just think of the frog with the top hat and the cane. Hello, my baby. Hello, my baby.
Please no.
So we just kind of covered this, and I'll pull it down so it's in the video. We just kind of covered this, but if you go to your glossary, because I had a couple people working ahead on their homework, and they came over to me and they're like, so theoretical, experimental, we don't know these things. And I was like, yeah, we haven't done that lesson yet. But you can always look things up. Now, I did help them, I told them, but it was because if you're working ahead, like expect to encounter some things you don't know. Probability, when properly notated, is this. P of A. A being the event that we want. So, just like what we just said, number of successful outcomes, or total outcomes, if you are a digital person, like Quinn likes to be on his book right now, this is actually a picture. When they give me things like this, it's an image. So I can save the image if I want. If you're trying to like keep a catalog or a Google Doc or something somewhere. And you can also copy out like the text with the image if you feel like it. So when we talk about coins, coins are often used in probability. And this is in your book, in your homework. So I'm not going to give you like the answer to this. But I got to explain to you what the difference between theoretical and experimental is. So read this for a moment. Theoretical probabilities. Same chance of winning means that it's a fair trial. So like every fish has equal chance. Not that green is equal to blue, but every fish has equal chance. Theoretical probability is based off the fact that theory is a word that means we know it. Okay, so a theory is something that we like know, have proven, whatever. Theoretical probability is based off observation, not doing something. I got a lot of eyes that are not up here, and I'm worried you're going to get to this problem on the homework and be stressed. Experimental probability is we did it. We tried it, we flipped it, we rolled it, we whatever the action is, we did it. So saying the probability of a coin is tails, if I didn't do it, that falls under theoretical. If I say the probability of tails and I have done an experiment to present that data, that's experimental. Two branches of probability. One, I got to do stuff. One, I just look at stuff. Leave that away. No, you're good. So check out 53. We are moving on to, actually, sorry. I tried to skip this. Look at that part. So I'm skipping a lot. Mr. Kabila totally just threw me off. Look at A because we want to talk about blue and yellow. We've already talked about green. As the tank is set up right now, real quickly jot down in proper notation P of blue, P of yellow, and we're going to write those fractions. Slow down here, I guess. So we write P blue equal fraction. Did I talk about us using fractions instead of percents? Yeah. I can't remember what I said in one class to the next because they're so close to each other. So how many blue fish?
3.
One fish, two fish, red fish, blue fish. How many total fish?
10.
10. That's it. That's all you gotta do. Probability is really easy once you get used to it. Well, we're now going to extend it. So then if you got asked percent, that's real easy too. How do I turn this into 100? Times 10, so we get 30%. When we talk about yellow, again, P of what we want. What's that? 6/10, and we could do the same thing, extending that to percent.
Oh, God.
Sorry, I don't know why that's in my head either.
Oh, no. I'm going to make it everyone else's head.
Now, this gets a little harder, but we're the advanced class, so that's okay. We're going to build a fish tank to change this game. Work with your team to decide how many fish of each color we would need to put in so that the probability of green is what is below. So, how do we set up the tank to make the probability of green be 2/7? B is different tank, right? How would we set up a tank to have probability of green be 5/7. C and D also different. So try those with your team. Try to agree with each other. We're running out of time, so I'm probably going to give you 3 minutes or less.
Three yellows.
Yeah. I don't get it. And then any amount of other 5.
And the next one, they're just crazy. Why would you put 8 out of 7 fish? I mean, I guess now they're going on to 200%. So I guess that's it. So 8 out of 7, yeah, we have 6 sevens. 4 yellow and 2 blue.
Oh, green.
So that's it. And then B is I am at a standstill.
You're supposed to.
Alright.
Are you supposed to put like a green fish on the floor?
I guess.
Into. We were Caitlin. Still gotta memorize your name. You look so much like previous student. Caitlin, how do I set up the fish to have a probability of 2/7 for green? So do you want to do 2 green or more than 2 green? Like, we have options here, really. You can do 2 green or 4 green or 6 green or 8 green or 10 green. 2 green? Okay, so 2 green. And what else? You guys did this, right? I mean, wings on C. So what did you guys say? 2 green. How many other fish do we still need? Yeah, we need 5 more to make 7 total. So I could either split those up into different colors or make my life easy and say, like, yeah, 2 green, 5 blue. There's no yellows in this one, I guess. Or we could do 4 blue, 1 yellow, or 2 blue, 3 yellow, or anything that makes 5. In B, Lizzie, how do I do 5/7? Lizzie's not really. You looked up, and I'm like, you're not Lizzie, but I'm just going to keep talking, so.
Just go to Cam.
Micah, we are to Micah now. How do I do 5/7?
5 green fish and 2 other colors.
Now, what have I told you? I have to use 10 green. I'm going to mess with you now.
Then 14 use 14 of the other colors.
14 of the others?
Why are you messing with us?
Oh,
You got this? You want 14.
4 other.
Ah! We want 14 total. If I double my numerator amount, I'm going to be doubling my denominator amount. Class 4. Gwendolyn, what's up with C?
So 7 green fish in the tank and put a green fish on the floor.
So Gwendolyn had this really creative idea. She asked me as I was walking around the room, she's like, so wait, C, do I like a green fish on the floor? Like, there's 8 green fish, but 7 in the tank? 1, don't put a fish on the floor. That's not nice. If you want to hear the story about my fish ending up on the floor, talk to me at lunch or something. I have a lot of stories. My life has been rather interesting.
No! No!
You can't do that.
Why not?
Probability. Hey, Nidden, same thing as yesterday. Will you guys dive into 133? Will you just tell your classmates? These guys are out of here in like 10 minutes or something. Probability has to be 1 or less than 1. Really, more so, it needs to be between 0 and 1. So depending on how much time we have today, we're going to end up making a probability line. But unlike a number line that keeps going, probability only exists between 0 and 1. It can be 0, it can be 1, but it cannot be more than 1. So if I look at D, so I heard the Y. This would be, I have 8 green fish out of 7 total fish. That doesn't make sense, right? You cannot have more of a piece than you have in the whole. Does that make sense? So 7 sevens. Can that happen? Do I have to only have 7 green fish?
Why would you do that?
Yeah. All that matters is it's all green. Because what is 7 sevens equal to? Any other number over itself. Right? Because really it's equal to 1. Does that make sense?
Yes, sir.
Now, I'm going to see how long we have and see if we have time for this challenge. Maybe 4 minutes. Let's try this.
Uh-oh.
So you guys are going to start to design your own game. You're going to start to design your own game. We are making a spinner game, and you'll learn about Phoenix Fair here in a little while. We're making a spinner game to try to make some money at this event. And yellow is going to be your big winner, right? So you guys have decided. Here's how we're going to break down our percents. Satya, have you been told by them? Just dive into 133. I'll be out to you guys in like 5 minutes.
Wait, what?
Dive into 1.3.3.
Okay.
So, try to design, now we're going to do round spinners, right? So, something like this, but obviously this one is not right. Try to design your own spinner to match this criteria. We're probably just going to do this for the rest of class, and then we'll talk more about it tomorrow. We will pick up in the lesson here. You got like 3 to 4 minutes to do this. Talk with your team. Try to figure out how to do like something like this, but with those probabilities. What up, dude?
Are you like after this you have lunch?
No. So now this year my schedule goes 3 classes straight through. So in the morning I teach 1A, 1B, 2A, as opposed to 2A used to come after lunch. 2A now comes after lunch.
Oh, well.
So I'm like done at normally 11:20. Today 11:24. But that's the longer answer of I'm probably not going to be in here after this because my kids, my 8th graders are already here, but they're like
Perfect. Barnard. He's on his way.
Nice.
And so I wanted to.
No, I haven't even heard him today.
Well, I still have it.
Yeah. And you said there's a way to walk around up in there?
Yeah, I don't know if it extends this far over.
Because somebody needs just a bright light up there.
Like, have you popped your ceiling tiles?
No, because it's too high.
Yeah,
I stood up. I can't get up there without a ladder.
I think that yours actually roofs off like right above it, and then it's that the library is the only area that we have catwalk access.
Hey, no one's heard the birds today, have you? The squeakiness that we sometimes have in my ceiling. Maybe you guys haven't noticed it because I'm too loud in class.
Well, I'm gonna have him come in and look.
Yeah, for sure.
There's
Thanks.
birds in the ceiling.
We're not sure. What? Yeah, no, so did
In
I.
the ceiling.
Yeah, we're worried that there's birds are able to like come in and out. There's
Birds
a
in our garage that come in and out.
there's a dude here to check right now. We keep one if we find them.
Really? No, like, keep it as pet.
I already have a bird and it is so loud. Sometimes I want to stab it.
Why?
Because of how loud it is.
So the spinner I showed you is broken up into 4 regions. What makes sense for you setting up a spinner using the information here? Savannah? So I'm going to start with just a circle, right? And Really, I'm out of time. I need to let you guys go. But if I'm going to start with a circle, because we're going to pick up here tomorrow, I got to decide, do I first start by just trying to make one of these 40% of the circle?
No, I don't.
Savannah?
I'll make it into like 10.
What were you going to cut? 10 sections, wedges? Like...
Yeah, I guess 10 pieces.
So what if we split this into tenths and go from there? We will pick this up tomorrow. All the time I got. Have a wonderful day, guys.
You too.
Thank you very much.
I will probably have to go to the Mets.
Same. That's like my